Hello, Professor Sargent here with you again for another one of our flipped classroom lessons for section 10.2, day 1. And in this lesson, we're going to learn that any real number can be an exponent. We've gone as far as having any integer and any rational number being an exponent. Now, any real number can be an exponent. And based on that, we can then talk about functions where the base stays constant, but we let the exponent be the variable. I'm going to show one example of each, and that will get you ready for Monday's class. And if that's enough for you, great. But I'm going to have further videos. These are digging back into my previous archive. So this first one, we're supposed to come up with an approximation of 3 to the 2.3. Since 3 squared is 9 and 3 cubed is 27, I expect something that is between 9 and 27. However, 2.3 is closer to 2, so that approximation should come out closer to 9. We're supposed to round this to 3 places. And so the particular scientific calculator that I used is going out a lot further than most handhelds would. Going to 3 places, look 1 place beyond that, and that means that the 3 is going to round up to 4. And my estimate that it would be between 9 and 27, but closer to 9, was correct. All right, now let's talk about graphing exponential functions. They are indeed functions. For example, y equals 4 to the x here. Everything you can put in for x, in fact, you can put in all real numbers, you're always going to get 1y out for the answer. Now, although the previous examples, we were putting in some semi-wild numbers for an exponent, that's not really necessary here. We can graph a rational function almost as easily as we can graph a line. If nothing is being done to the exponent, then we can put in some typical values of x, -1, 0, and 1. And the reason why we're choosing -1, 0, and 1 is that 4 to the -1, that gives you the reciprocal of 4, 1/4. 4 to the 0 is 1, and 4 to the 1 is 4. So we're going to be plotting -1, 1/4, 0, 1, and 1/4. And that's going to be enough to let us see what this curve looks like. So here's -1, 1/4 approximately, 0, 1, and 1/4. Notice on the left-hand side, when we connect here with a smooth curve, that it's growing kind of slowly, and then when we cross the y-axis, it's growing a lot more quickly. Also, the x-axis here is acting as what's called a horizontal asymptote. That means to the far left in this case, the behavior of the graph, it is acting more and more like the horizontal line. Furthermore, y is staying greater than 0. It's never going to hit the y-axis, let alone cross it. So y is strictly positive, and any horizontal line is going to cross no more than once. So not only do we have a function passing the vertical line test, it's passing the horizontal line test, giving us a one-to-one function. That's going to be useful in just a bit. Would you like to learn more? Keep on watching. Here we're also supposed to approximate. Now, if that was positive, 5 squared would be 25, and 1/25 is 0.04. 5 cubed is 125, so 1 over 125 would be smaller than that. The reason I bring up 1 over 25 is that negative exponent. Five to the 2.4, but change the sign. This is coming out smaller than 0.04, what I was mentioning earlier. Again, rounding to 3 places. After the 1, we've got a 0. That rounds down to 0.021. One last one where we're supposed to approximate. 1/3 to the 2.9. If that was 1/3 squared, I would say 1/9, which is approximately 0.11. And if that were 1/3 to the 3, I'd have 1 over 27, something even smaller. So I expect something smaller than 0.11. One-third to the 2.9. That is smaller than 0.11. Three places. After the 1, we've got a 3. It's going to round down to 0.041. To graph y equals 1/4, all of that to the x. I'm going to use the same values of x. 1/4 to the -1. It's going to flip that, give us the reciprocal. 1/4 to the 0 is still 1. And 1/4 to the first power is just 1/4. So the points I'm plotting are -1, 4, 0, 1, and 1, 1/4 right about here. Connect them with a smooth curve. Once again, this time at the far right, you see that it's going to act more and more like the horizontal line y = 0. And this will pass the horizontal line test. So it's a function that's 1 to 1. To graph y = 4 to the negative x, we've changed the sign of the exponent. So 4 to the negative of -1 would be 4 to the 1, or 4. 4 to the 0, well, -0, but that's still 0. So 4 to the 0 is still 1. And then 4 to the -1, or 1/4. We're actually seeing the same points that we had when we graphed the previous one. And that's because 1/4 to the x is equal to 4 to the -x. That's why the first one, as we look left to right, it was increasing. The second one was decreasing. This one is the same as the second function. And so we see that it is decreasing.
So apparently my mic was on mute when I recorded this. We're going to do a voiceover. We're going to take a look at one more graph of an exponential function, but a little more is being done to x before we use an exponent. What I'd like to do is get the same y values that we had earlier. And so the 4x plus 2 in the exponent is what we have to get equal to -1, 0, or 1. So I'm going to solve 4x plus 2 equaling those special values of what I was originally using for x. In each case, subtract 2 from both sides to combine like terms, and then divide by 4. In this case, -2/4 is going to reduce to -1/2. So I'm going to look at the first and third columns for the points to be plotted. We'll have -3/4, comma 1/4, -1/2, comma 1, and -1/4, comma 4 to plot. When we connect these 3 points, we're going to get something that's steeper than in the previous examples because of the change of x to 4x plus 2 before we put it in the exponent. However, we still get y = 0, i.e. the x-axis as a horizontal asymptote. And even more important, we're going to have a function that is passing the horizontal line test so that it is one-to-one. And we're about to use the fact that exponential functions are one-to-one in solving exponential equations.
And that's all I have. Hope this helps. I'll see you in class.